Hi everyone, welcome to the course on chemistry, that is general principles and processes of isolation of elements. So it is one of the easiest chapter and you will get one question from this chapter in all entrance examinations like CET, NEET or JEE. Now we will solve the questions on this chapter. Before solving the questions, first we will see some theoretical part related to this chapter. So first you should know what are ores, that you have already learnt in regular theory classes. These are the minerals which consist of a metal and you can extract that metal more conveniently and economically. Then only that type of mineral is considered as ore. And there are different types of ores that you can observe here. The first one is native ores. Native ores means these ores contain the metal in free state. For example, silver and gold. These are usually formed in the company of rock or alluvial impurities like clay and sand. So these are present in free state, means they do not react with any other element or they do not combine with any other element. They will obtain as in pure state. And the second type of ores are oxidized ores, or you can say oxide ores. So these ores consist of oxides or oxysalts. For example, carbonates, phosphates. So they consist of oxygen, hence such salts are said to be oxysalts. And silicate of metal. Important oxide ore includes Fe2O3, Al2O3, 2H2O, etc. And important carbonate ores are limestone and calamine, that is zinc carbonate. So another third type of ores are sulfurized ores or sulfide ores. So these consist of sulfides of metals like iron, lead, mercury, etc. Examples are iron pyrites, FeS2, galena, PbS, cinnabar, HgS. The fourth type of ores are halide ores. Metallic halides are very few in nature. Chlorides are most common examples, include horn silver, that is AgCl, carnallite, KCl, MgCl2, 6S2, and fluorspar, that is CaF2. So remember these ores and their chemical formulas. Try to remember more and more number of names of the ores and their chemical formula, because they are very important from the exam point of view. So next we will move to metallurgy. So what does this metallurgy means? As you know, the metal is extracted from ore and we will carry out certain technical and scientific processes, and those processes are considered as metallurgical processes. This overall extraction of metal from its ore by carrying out certain scientific and technical processes is said to be metallurgy. So how this metallurgy is done? That means how the metal is extracted from its ore. It mainly involves 4 steps. Those are crushing of the ore, the first step. There the huge lumps of ore are crushed and grinded with the help of ball mills and stamp mills. Then the dressing or concentration of the ore, that means removal of impurities which are associated with ore. Those impurities are also known as gangue particles. So removal of gangue particles is considered as dressing or concentration of the ore. Then third one is reduction of metal, or you can also say isolation of metal from concentrated ore. So once the ore is concentrated, we have to extract the metal. That can be done by reduction process. And the fourth one is purification. After obtaining the metal, it still consists of certain impurities, and those impurities are removed from the metal, and that removal of impurities from the metal is said to be purification or refining of the metal. So these are the 4 steps that are involved in metallurgical processes. Then, as you know, crushing of ore is done by using ball mills and stamp mills, which is converted into powdered ore, and that is known as pulverization. And now the second step is concentration. That can be done by various methods, physical methods as well as chemical methods. So here we will see some of the chemical methods, physical methods, like gravity separation. Okay, this is physical method. Froth flotation process, one of the important process. Okay, so what does gravity separation means? The powdered ore is agitated with water. The heavy particles, that is ore particles, settles at the bottom, and sand, clay are washed away with water. And froth flotation, it is mainly dependent on specific gravity. Okay, specific gravities of ore and impurities, this gravity separation. Then the froth flotation process, it is dependent on wettability property. Okay, based on wettability property, wettability of ore with oil and impurity with water, the froth flotation process is carried out. And it is it is mainly applicable to the sulfide ores. Okay, what happens here is the finely divided ore is introduced into water containing a small quantity of oil, that is pine oil. The mixture is agitated violently with air. A froth is formed which carries away along with it the metallic particles on the account of the surface tension forces. The froth is later skimmed off and later it is dried off. Then here we will use certain chemicals. Those are activator, depressants and collectors, which are used in froth flotation process. So what is activator, depressant and collector? Activator means they activate the floating property of one of the component of the ore and help in the separation of different minerals present in the same ore. And here CuSO4 is used as activator. Then depressant. These are used to prevent certain types of particles from forming the froth with air bubbled. Example, NaCN can be used as depressant in the separation of ZnS and PbS ores. KCN is also example of another depressant. Then collectors, it increases the non-wettability of ore particles by water. Example, pine oils, xanthates and fatty acids are used as collectors. So these are very important chemical substances which are used in froth flotation processes. And remember these terms and examples of those terms. Another method of concentrating the ore is electromagnetic separation. It mainly depends upon the magnetic properties of ore and impurities. So one of the either ore or the impurities should be magnetic, but not both the ore and impurities must not be magnetic. Only one of them should be magnetic, then only we can use the electromagnetic separator process. So here simply a moving belt is present on the magnetic rollers, two magnetic rollers. One is magnetic roller and another one is non-magnetic. Okay, if we consider it is magnetic, then it is non-magnetic. Okay, so here upon pouring the ground ore on the belt, moving belt, the non-magnetic materials move away from the roller and magnetic materials move near to the roller, and hence the impurities and ore particles gets separated out. And examples is chromite containing magnetic siliceous gangue and wolframite, okay, containing cassiterite, can be separated by this method. Then chemical methods. So you have seen physical methods, and now what are the chemical methods that we will see? The first one is leaching. It is the process of concentration where we use certain chemicals which are reagents which dissolves the ore but not the impurities. Examples are bauxite is leached with a hot concentrated solution of NaOH, okay, which dissolves aluminium, and while other oxides will remain undissolved. And noble metals are leached with dilute aqueous solution of NaCN or KCN. Noble metals means silver and gold. These are leached with aqueous solution of NaCN or KCN in presence of air. So this is the reaction which is involved in the leaching of bauxite, that is alumina, and leaching of silver as well as gold also represents the same reaction. And here this process is known as cyanide process. The extraction of the gold or silver from its ore is considered as cyanide process. And this leaching of alumina from bauxite ore is said to be Bayer's process. Okay, it is Bayer's process, and it is said to be cyanide process, or also it is known as MacArthur Forest process. The next one is extraction of crude metals from concentrated ore. So the third step after concentrating the ore, it involves two steps, that is conversion of oxides and then reduction of metals. So how to convert a ore into oxides? This can be done by two ways. One is calcination and another one is roasting. So what does this calcination means? It is the process of heating ore in absence of air or in limited supply of air below its melting point. Okay, air is absent or limited air will be supplied, and during this calcination volatile impurities are removed as well as organic impurities are removed, and moisture is also removed. And after this, the main thing is carbonates gets decomposed to oxides. Okay, so calcination, it involves the decomposition of carbonates to their oxides. Okay, and it is carried out in reverberatory furnaces. Only calcination used for metal carbonates and hydroxide. Okay, then the second one is roasting. Here it is the process of converting an ore into its metallic oxide by heating it strongly below its melting point in excess of air. Means in presence of excess of air, we will heat the ore to convert that into oxide, and it is mainly carried out for sulfide ores. Roasting is carried out for sulfide ores, and it takes place in reverberatory furnace or blast furnace, and this also removes the non-metallic impurities, moisture, organic matter, all those things. Some of the examples are ZNS. When heated in presence of air, it will form zinc oxide. So here sulfide ores are mainly carry out this roasting process. Okay, then reduction of oxides to metal. After converting the ore to oxides, those oxides of metals gets reduced, and this can be done in different ways. and all this involves the heating process with suitable reducing agent. Now if the extraction of metal or reduction of metal takes place with the carbon as a reducing agent, then it is known as smelting process. So reduction with carbon is known as smelting. And these are all pyrometallurgical processes, means all this involves heating process. Some of the examples are given here. And during this smelting, certain substances called flux are added, which helps to remove non-fusible impurities as slag. This slag is insoluble in molten metal and is lighter than molten metal. So it floats over the molten metal and is skimmed off. So certain impurities which are still present in the ore can be removed with the help of flux. And here different fluxes are used based on the nature of impurities. So acidic flux is used for basic impurities and basic flux is used for acidic impurities. So how to find out whether the impurity is basic or acidic? Simply remember the non-metallic oxide. So silicon is a non-metal, it is oxide. So non-metal oxides are acidic in nature, and metal oxides or metal carbonates oxides are basic in nature. Metal oxides or carbonates, okay, they are basic in nature. So if non-metal oxides are there, they are acidic. So here, see, it is a acidic flux here. We have used acidic flux. So here impurity is metallic oxide. So it is a metallic oxide, hence it acts as a basic impurity. For basic impurities, we will add acidic flux. Okay. And for acidic impurity, that is silicon dioxide is acidic. So for this kind of impurities, we will use a basic flux. Okay, that is magnesium carbonate or calcium carbonate. So whenever acidic impurities are there, basic flux should be added. Basic impurities are there, basic impurities are there, then we have to use acidic flux. Okay, these are the examples. Next, reduction by hydrogen. By using hydrogen, we can reduce tungsten or molybdenum. Okay, this is one of the example. Then another one is reduction by aluminium. So aluminium is used as reducing agent for reducing different metals. For example, chromium oxide can be reduced with the help of aluminium and forms aluminium oxide and chromium. And this is aluminothermic reduction or Goldsmith thermite process. So aluminium powder is used for this purpose. Remember, the mixture of oxide and aluminium in the ratio 3:1 is known as thermite. Okay, remember, very important. Thermite means it is the mixture of oxide and aluminium in 3:1 ratio. And mixture of barium oxide and Mg powder acts as ignition powder. Okay, so these are very important, remember this. Then another type of reduction is auto reduction. Means some reaction they will themselves undergo reduction. So examples are Cu2S3O2 gives Cu2O 2SO2. This Cu2O it will reduces Cu2S and forms Cu and SO2. So this is self reduction or auto reduction process. Here no reducing agents are used. And reduction by Mg. So remember, TiCl4 titanium chloride when reduced with Mg forms MgCl2 and titanium, and this is known as Kroll's process. Okay, electrolytic reduction or electrometallurgy. It is used only for the metals which are highly electropositive like sodium, potassium, calcium, magnesium. Okay, so These are certain reduction processes. The next, thermodynamic principle in the extraction of metals. This can be done or explained with the help of a diagram. You can observe here, this is the diagram, and this diagram is known as Ellingham diagram. And the feasibility of the reaction can be obtained or known by using this equation, which is known as Gibbs-Helmholtz equation. So delta G is equal to delta H minus T delta S. It explains about the whether the reduction process will take place with the reducing agent, the given reducing agent or not. And here some conditions you have to remember. If delta G is negative, then the process is spontaneous and the reaction will take place. If delta G is positive, then it is non-spontaneous and reaction will not take place. And if delta G is equal to 0, then it is in equilibrium. So for a reaction to be takes place, the process should be spontaneous, and it is spontaneous if delta G is negative. So condition for a reaction is delta G should be negative, then only the reaction will take place. Now fourth step is refining or purification of crude metals. So after the reduction we will obtain the metal. That metal consists of certain impurities, and the metal which consists of impurities is said to be crude metal, such as slag, flux, all those are added, and some of the quantity of those substances will remain with the metal, and hence it is known as crude metal. So we have to remove the impurities which are present in crude metal. That process of removal of impurities from the crude metal is known as refining of metal. And now there are different physical methods as well as chemical methods are there. So some of them we will see here. First of all, liquefaction, the first method. So it is used for the refining of metals having low melting points. For the low melting points, metals can be refined by using liquefaction process, and examples are tin, lead, Hg and bismuth. And the second one is distillation. This is useful for low boiling metals such as zinc and mercury. Okay, so remember these processes and for which type of metals these processes can be applied. Next, the third one is cupellation. So this method is used when impure metal contains impurities of other metals which form volatile oxides. For example, traces of lead are removed from silver as volatile lead oxide by this process. Okay. Then chemical methods. First one is pooling. So this method is used when the impure metal contains impurities of its own oxide. Examples are given here. Okay. So here we will use the impure metal is stirred with green wood poles. Hence it is known as pooling method. Next, another one is electro refining. So here the electrolysis process takes place and electrolytic reduction will take place, and the metals which can be purified or refined by using electrolytic refining are Cu, Ag, Au, Cr, Zn, nickel, etc. Then the third one is zone refining. This method is based mainly on the principle of fractional crystallization or difference in the solubilities of impurities in molten and solid state of the metal. That means the impurities are more soluble in molten state than in solid state of the metal, and hence this method is used in such cases. And semiconductors like silicon, germanium, gallium arsenide and indium antimonide are purified by this method, and this is applied only if the elements are required in very high purity. Okay, so these are certain chemical methods. Another one is vapor phase refining. It is also one of the important refining method, vapor phase refining. In this method, crude metal is made free from impurities by first converting into its stable volatile compound by heating with a chemical reagent at low temperature. And then it is decomposed to give pure metal. Some of the methods involved in this are Van Arkel method and Mond's process. Van Arkel method is used to purify titanium and zirconium, which is used for preparing ultra pure metal used in space technology, titanium, zirconium. And the next one is Mond's process. It will also involve vapor phase refining, and nickel can be purified by Mond's process. Then the next one is chromatographic method. So it mainly works on adsorption chromatography. Okay, adsorption process is involved, and by using chromatographic method we can also obtain the pure metal. So these are certain methods to refine the metals. Then some of the metals, how they are extracted, what are the sources, that here given. So simply we will glance these things. First one is aluminum, occurrence, bauxite or cryolite, mainly obtained from, here you have learnt about bauxite, how to extract the aluminum from bauxite. And common method of extraction is electrolysis of aluminum oxide, that is alumina, dissolved in Na3Al(F6), that is cryolite, which is a neutral flux, and it is added to the ore to decrease its melting point and to make it conducting. Remember this. Example, CaF2 cryolite. These two things, neutral flux, examples are CaF2, calcium fluoride and cryolite. These are added in order to decrease the melting point and to make it conducting. Then third one is iron, Fe. Its important ores are hematite and magnetite, and these are the chemical formulas, Fe3O4. The common method of extraction is reduction of oxide with CO and coke in blast furnace. Okay, and there are different types of carbon are obtained at the end of the process. If the iron consists of 4% of carbon and other impurities, then it is known as pig iron. And another type of iron is cast iron, so which is different from pig iron, and it is made by pig iron by melting it with scrap iron and coke using hot air blast. It has slightly lower carbon content, around about 3%, and it is extremely hard and brittle. Remember the properties of these three types of iron. And the third one is wrought iron or malleable iron. It is the purest form of commercial iron. So it is prepared by oxidizing impurities in a reverberatory furnace, which is lined with hematite. So this is the reaction that you can observe here. Okay. Next, copper. So occurrence of copper is by copper pyrites and copper glands. Remember the chemical composition. Okay. Common method of extraction: roasting of sulfide partially and reduction. CO2 and FeS, important composition, which is called copper matte. Blister copper contains 96 to 98% of copper with small amounts of Ag and Au as impurity. Then the zinc occurrence: zinc blend or sphalerite, that is ZnS, calamine ZnCO3, zincite ZnO. The common method of extraction is roasting followed by reduction with coke. And metal may be purified by fractional distillation or electrolytic refining. 97 to 98% of pure zinc is called spelter. So important one. So these are certain metals and their occurrence and how they are extracted, you can see. Now we will move to the questions. First one, galena is an ore of. So what is galena? What is the chemical composition of galena? It is, first you should know, if you know the formula, that is why I have already told you. Remember the chemical composition of ores as much as possible. So galena, it is represented as PbS, that is lead sulfide. So it is the ore of lead, Pb, option A. And Hg, it is also, remember, cinnabar, HgS. So cinnabar is ore of Hg. And zinc, you have many things. Okay, you can remember any 2-3 ores. Okay, so option A is the right one. Then second one, the impurities associated with mineral used in metallurgy are called collectively. As I already told you, when you obtain the mineral and when you get the ore, that ore consists of many impurities, and those impurities associated with ore are gangue particles, or they are also known as matrix. A gangue or matrix. And you know, flux means it is the chemical reagent added to remove the gangue particles from ore. And slag is the combination of flux and impurities to form slag. Okay, so D, ore, that is already known. So option C, gangue, is the right one. And third one, froth flotation process is used for the metallurgy of. So as I already told you, froth flotation is mainly made for lighter ore particles, and sulfide ores are lighter ore particles, and hence the option D is the right one. That is, sulfide ores. Froth flotation process is used for the metallurgy of sulfide ores. Okay. Then fourth one, while extracting an element from its ore, the ore is grounded and leached with dilute potassium cyanide solution to form the soluble product potassium argentocyanide. The element is, so when leaching process comes, you will go through two processes. One is leaching of alumina, where bauxite is leached, and another one is cyanide process. In a cyanide process, we will use KCN or NaCN. In the leaching of alumina, we will use NaOH as a reagent, and in cyanide, we will use KCN or NaCN. And cyanide process is used for silver and gold. And remember, here the potassium cyanide solution is used. So it is the extraction of Ag or Au. But what it will forms? It forms potassium argentocyanide. So argento, that is nothing but Ag, means silver. So the element silver, option D, that is element silver is obtained or leached by using potassium cyanide solution. Option D is the right one. Then fifth one, leaching is a process of reduction, concentration, refining, oxidation. So leaching, it is one of the chemical method which is used to remove the impurities present in the ore, and that is known as concentration of ore. So leaching is a process of concentrating the ore by using suitable reagent. Option B. Then sixth one, froth flotation process is based on wetting properties of ore particle, specific gravity of the ore particle, magnetic properties of ore particle, electrical properties of ore particles. So here you already know froth flotation is an important process which is used for sulfide ores, and it depends upon a wetting properties of ore particle. So option A is the right one. B, specific gravity, it is used for gravity separation. Magnetic properties, magnetic separation. Electrical properties, electrolytic. reduction or electrolysis, there we will use different methods. Okay, so for froth flotation it depends upon wetting properties of ore particle. So option A is the right one. Then seventh one, roasting is generally done in case of the oxide ores, silicate ores, sulfide ores, carbonate ores. So rusting is carried out for sulfide ores. And when, what does this rusting means? It is the heating of ore in the presence of excess of air in order to form oxides. Okay. So here it is applicable to sulfide ores. That is option C. For carbonate, oxide and silicates, most oftenly we use calcination process. Okay. So option C is the right one for 7th question. 8th one, the role of calcination in metallurgical operations is to remove moisture. Yes, calcination means what? It is the heating of ore below its melting point in a limited supply of air or in the absence of air. When we heat, it will remove the moisture. Yes, then it will decompose the carbonates to oxides. Okay, you can see the reaction like this during the calcination. Carbonates decomposes to oxides along with the liberation of carbon dioxide. And it dry off organic matter. Yes, it removes the organic matter to decompose carbonates and dry off moisture and organic matter. So among these three, A is also right, B is also right, C is also right. Okay, but all these are right. But option D, it involves all the three options. That is, it decomposes carbonates, dry off moisture and organic matter. So which option is the right one? Option D. Okay, option D is the right one. The role of calcination in metallurgical operations is to decompose carbonates and dry off moisture and organic matter. Then 9th one, the function of the flux added during smelting is. Why the flux is added? Smelting means what? Reduction of metal with the help of carbon as reducing agent. So during that smelting, flux is added. Either it may be acidic flux or basic flux. So why it is added? It is added to remove the gangue particles. That is, to remove the impurities which are further present in ore. So option B, to remove gangue. Gangue means what? Impurities. Gangue or matrix, you can say it as matrix also. So impurities. To remove impurities, we will add flux. Option B is the right one. Then 10th one, when a metal is to be extracted from its ore and gangue associated with the ore is silica, then so silica, what is the formula of silica? SiO2. SiO2, silicon dioxide. It is the chemical formula of silica. Now which flux should be added to remove the gangue associated with ore? This silica. So silica is an impurity. So silica non-metallic oxide, so it is acidic in nature. So we need to use basic flux. Okay, such as calcium oxide. Then we will add the basic flux. It will form silicate, which is known as slag. So which type of flux is needed? A basic flux is needed and not an acidic flux. Acidic flux is needed for basic impurity. Okay, and both acidic and basic flux are needed? No need, because only silica is present. So neither of them is needed, not at all, because the gangue particles are present. So we have to remove them. To remove them, we will use basic flux. Option B is the right one. 11th one, the cast iron is made by melting pig iron with scrap iron and coke using hot air blast. Yes, this one is right. After obtaining pig iron it consists of 4% of carbon. It can be further purified by melting that with scrap iron and coke using hot air blast to obtain cast iron, which consists of 3% of carbon. Next, having slightly lower carbon content, about 3%, so this is also right. Extremely hard and brittle, yes, if you go through the synopsis, there you can see these three properties of cast iron. Hence, before solving the questions, be perfect in theory part, so you can easily solve the questions on this chapter. So, one of the easy chapter, if you know the theory very well, then you can easily get the answer for the question from this chapter. So option D, all the above statements are true. So A, B, C, all are correct. So option D is the right one. Then 12th, extraction of zinc from zinc blend is achieved by. So how does this zinc is obtained from zinc blend? Zinc blend is ZnS. So this can be obtained. See, simply option electrolytic reduction, roasting followed by reduction with carbon, roasting followed by reduction with another metal, roasting followed by self reduction. So Zn is there, S is there. First we have to convert that into zinc oxide and then reduce to zinc. So first what we have to do, zinc sulfide should be heated in presence of excess of air. In order to get, what you will get? You will get 3Zn plus 3SO2 oxide, 3 oxide plus this should be 2. So 2ZnS plus 3O2 gives 2ZnO plus 2SO2. Then after getting the zinc oxide, reduce this with the carbon, what you will get? Zinc. So this is the method which is used to extract zinc from zinc blend. So first heating the zinc sulfide in presence of excess of air, that is roasting. First roasting is followed, then it is followed by reduction with carbon. So option where it is there, reduction with carbon. So option B is the right one. The 12th one, the answer is B. Next 13th one, the electrolytic method of reduction is employed for the preparation of metals that are weakly electropositive, moderately electropositive, strongly electropositive form oxides. So this electrolytic method reduction is for strongly electropositive metals like Na, K, Ca, Mg, etc. Okay. So electrolytic reduction is used for strongly electropositive metals. 14th, the furnace used to prepare commercial iron is lined with which of the following? So it is lined with hematite. Okay. So hematite is used in reverberatory furnace, and option A is the right one. 15th one, the process of zone refining is used to purify these semiconductors like silicon, germanium and gallium. So here in this, the 15th question, option A is the right one. And 16th one, Van Arkel method of purification of metals involves converting the metal to a volatile stable compound, volatile unstable compound, non-volatile stable compound, and none of the above. So Van Arkel method is used to purify titanium and zirconium. So if I consider the example, titanium, when it is heated with in presence of iodine vapor, what it will form? Titanium iodide, which is the volatile stable compound. First it will form volatile stable compound. Upon further heating at high temperature, it will form titanium plus 2I2. It will decompose this and gives pure titanium. So it involves formation of volatile stable compound. So which option is right? Option A. 17th, which of the following pairs of metals is purified by Van Arkel method? So in previous question only I have told you Option B, zirconium and titanium. 18th one, pyrolusite is an. What is the composition of pyrolusite? MnO2. So which type of ore it is? Oxygen is there, so it is an oxide ore. Option A is the right one. Option A. In the extraction of chlorine by electrolysis of brine, what does takes place? So how you can represent the reaction? Extraction of chlorine by electrolysis process of brine. Brine means aqueous solution of NaCl is said to be brine. During the extraction of chlorine by this electrolysis, the reaction can be represented as 2Cl minus plus 2H2O gives 2OH minus plus H2 plus Cl2. This is obtained. So from this, what does takes place? Whether the oxidation takes place or reduction takes place. So here you can see not only oxidation and reduction takes place. For overall reaction, the delta G value will be negative. Delta G value for this reaction will be negative. Okay. So actually here Cl minus, it gains the electrons. So reduction will takes place. Reduction will takes place. And here H2O will get converted into OH minus. Oxidation will takes place. Okay. And for overall reaction, the delta G has a negative value. Hence, option third is more accurate. Okay. Reduction of Cl minus will also takes place. But for overall reaction, delta G has a negative value. So option C is the right one. That is third. 20. A number of elements are available in earth crust, but most abundant elements are. So most of the elements are obtained from the earth crust. Most abundant element in the earth crust is oxygen. Okay, most abundant first. The second most abundant element is silicon. The third most abundant element is aluminum. Fourth most abundant element is iron. So these two are non-metals. When we consider the metals, the most abundant metal is aluminum. The second most abundant element is iron. So the most abundant elements available in the earth crust, which are metals, are among these four options. The most abundant one are aluminum and iron. So option 1 is the right one. 21st. Zone refining is based on the principle that. So if you go through the synopsis, again you will directly get the answer for this. That is, impurities are more soluble in molten metal than in solid metal. It is fractional crystallization. It depends upon the principle of fractional crystallization. Okay, which explains the impurities are more soluble in molten state than in solid metal. Option 2 is the right one. So 22nd. In the extraction of copper from its sulfide ore, the metal is formed by the reduction of Cu2O with what? Auto reduction, that is Cu2S. What it gives? It gives 6Cu plus SO2. So here 2Cu2 plus Cu2 gives 6Cu plus SO2. This is the another metal, that is Cu2S. Option third is the right one. It is an example of auto reduction. Then 23rd, in the metallurgy of aluminium, Al plus 3 is oxidized to aluminium. Is it right? Al plus 3 is oxidized to aluminium. It is reduced to aluminium, not oxidized. Okay, graphite anode is oxidized to carbon monoxide and carbon dioxide. So this is the right one. Oxidation state of oxygen changes in the reaction at anode. No. Oxidation state of oxygen changes in the overall reaction, not in the process. So option 2 is the right one. 24th, extraction of gold and silver involves leaching the metal with the Cn minus ion. The metal is recovered by, how it is recovered? Displacement of metal by some other metal from the complex ion, roasting of metal complex, calcination, thermal decomposition of metal complex. So it involves displacement of metal by some more electropositive metal like zinc from the complex ion. So this is the right answer. Option 1 is the correct one. 25th, which of the following statements is correct about the role of substances added in the froth flotation process? So 25th, here collectors enhances the non-wettability of the mineral particles, that is ore particles. Is it right? Yes. So remember the theory, so you can answer this. Collectors enhances the wettability of gangue particles. Is it right? No. It only enhances the non-wettability property of mineral particles. Okay, but it does not increase the wettability of gangue particles. Third, by using depressants in the process, two sulfide ores can be separated. Yes, by using depressant like NaCN, we can separate the PBS and ZNS. Next, fourth one, froth stabilizers decreases wettability of gangue. So it is wrong statement. So among these, two statements are right, 1 and 2. So it is a multiple choice question having two answers. This type of questions will also asked in JEE. Okay, so option 1 and 3rd, you have to tick both the answers. Option 1 and 3rd are right one. 26th, in froth flotation process, zinc sulfide and lead sulfide can be separated by, how they are separated? Zinc sulfide and lead sulfide. One of the common thing that you know is using depressant. Depressant can be used, and also adjusting the proportion of oil to water. This is also the another important thing that you should know. Some of the ores are obtained by adjusting the proportion of oil to water. Then we will add certain depressant to separate the two sulfide ores. So second and third both are correct statements. 27th, which of the following ores are concentrated by froth flotation process? So as you know, froth flotation process is used to concentrate the sulfide ores. So hematite, its chemical composition is Fe2O3. It is an oxide ore. Magnetite, Fe3O4, it is also an oxide ore. Galena, PBS, copper pyrites, CuFe2S, FeS2. So here the copper pyrites and galena, these are sulfide ores and which are used to concentrate by using froth flotation process. So second and third are right. 28th, in which of the following method of purification metal is converted to its volatile compound which is decomposed to give pure metal? So heating with the steam of carbon monoxide, heating with iodine, liquefaction, distillation. 28th, if you observe vapor phase refining, first it is converted to volatile, stable volatile compound, that is heating with steam of carbon monoxide in the extraction of nickel. Okay, how you will extract? You will extract it by NiCO4. Next, heating with iodine. This is also the right one. Okay, because in extraction of titanium and zirconium we will use iodine vapors. liquefaction and distillations are not correct. So option 1 and 2 are right one. 29th, which of the following statements are correct? A depressant prevents certain type of particle to come to the froth. Yes. Copper matte contains Cu2S and ZnS. No, it contains Cu2S and FeS. So this is wrong statement. The solidified copper obtained from reverberatory furnace has blistered appearance due to evolution of SO2 during the extraction. Yes, which is known as blister copper, which is due to evolution of SO2. Zinc can be extracted by self-reduction. No, it is extracted by reduction with coke or carbon. So 1 and 2 are right statements or correct statements. 30. Electrolytic refining is used to purify which of the following? So germanium and silicon obtained from zone refining, zirconium and titanium vapor phase refining, okay, and zinc and mercury are obtained by distillation, okay. Then copper and zinc, these are obtained by electrolytic refining, okay, electrolytic refining. So option 1 is the right one. 31st, in the extraction of aluminium by Hall-Herold's process, purified Al2O3 is mixed with calcium fluoride, that is a neutral flux. Calcium fluoride, or you can also use Na3AlF6, that is cryolite. What is the advantage of that? It lowers the melting point of Al2O3, right on. Increase the conductivity of molten mixture. Reduce Al plus 3 ions to Al. So here first one is right. Second, it increases conductivity also. Reduce Al plus 3 into Al. No. Acts as a catalyst. So these two statements are wrong. The correct statements are 1 and 2. Or correct answers are 1 and 2. So option 1 and option 2 are right one. So these are certain questions which are important from the chapter General Principles and Processes of Isolation of Elements. Okay, go through the theory part, then you can able to answer to the questions very easily. Thank you.